All right, critical value, critical value, critical value. What makes the critical value a critical value in here? Critical value. It's where the slope of the function is 0, the derivative is 0, or does not exist. But what about the function value there? It has to be in the domain. The function value has to exist there. Again, it doesn't mean it has to be continuous. It could be something like this at x equals, I don't know, let's call it 3. Okay? Is f of 3 in the domain of this function? If this is the function f? Yeah, it's that value right there. Would x equals 3 then, by definition, be a critical value? Yes, because what's the value of the derivative there? dne. Okay? If that dot were not there, would x equals 3 be a critical value? No, it would not. The derivative still doesn't exist there, but the function doesn't. And so it can be a critical value if it's not a value of the function. Okay? It's still a very important value, but we don't call it a critical value. All right, so that leads us to this theorem. Absolute max-mins, global max-mins, or max-mins, right? Either one of those, they're all the same thing, can only occur at a critical value or at an endpoint. And I list those separately, even though they're going to be critical values, because the derivative is undefined. They're so special, we'll just throw them in there. It's a critical value or an endpoint of an interval. Those are the only places absolute max or mins can occur. All right, so before we set out to try and find them analytically, we need to address another type of extreme value, right? One that Mr. Armstrong brought up yesterday. Okay, so these are called either relative max-mins, relative extrema, or local max-mins. Now, the slash means that those two names are interchangeable, like absolute and global. But are they in parentheses? No. So that means that they are not optional. Meaning if you want to refer to these types of max-mins, you need to say either relative max-min or local max-min. Because if you don't say relative or local, everybody's going to assume you're talking about what kind? Global, all right? Now, if you do want to pair them up, relative kind of pairs nicely with a white line. An absolute extrema. And local pairs nicely with a global. Okay, right? The terminology goes together. Absolute, relative, global, local. Right? Okay, cool. So what the heck are these fellas and how are they similar to the other fellas? Well, very, very important. If there exists an open interval, ooh, that's important. I'm going to circle that. I'm going to highlight that. I'm going to circle it again. Then I'm going to highlight that circle. An open interval. If there's an open interval containing an x value, that means values live to the left and right of it. Immediately to the left and immediately to the right. If, number one, immediately to the left of C and immediately to the right of C, there are no y values bigger than it, then it's going to be a relative max or a local max. If you look immediately to the left and right and you don't find anything higher, then that's a local max. If you look immediately to the left and right of that x value and you find nothing smaller, then it's a relative or local min. In other words, if there exists an interval, a small enough open interval containing an x value such that it's the location of an absolute max on that interval, it's a local max. And if there exists a small, local, relatively small interval where it's an absolute min, then it's a local min. Okay? Very, very, very important. So like if you come back way up here to our first one, this was the absolute min. Could that be also a local min? Let me make sure I'm not doing this down below again. Oh, I'm doing it down below again. Let's jump down to example 4. All right. It says example 4. We'll come back up here. Example 4. Identify all the critical values and show below and determine if they're local max or min. So I probably shouldn't have skipped this. Here's another theorem. Local extrema or relative extrema. Local max-mins, relative max-mins can only occur at a critical value on what type of interval? Open interval. It has to be on an open interval. So, what's the upshot of that? Can we call endpoints critical values? No. Okay, actually we can call endpoints critical values. I'm sorry, I phrased that wrong. Endpoints can be critical values. Can endpoints be the locations of local extrema? No. No. Because we can look left of the left endpoint or right of the right endpoint. So as we look at example 4, I'm watching the clock here and it's making me nervous. Let's go ahead and list the critical values. All right. G, we'll do it down here. G of X has critical values, which I'll abbreviate CVs, at, and let's just list them, X equals. All right. Is A a critical value? Is it a critical value? Yes, it is a critical value. It's in the domain, and the derivative doesn't exist there. So it is a critical value. Okay, comma. Is B a critical value? It's in the domain, and the derivative there is 0. So yes, it is also a critical value. Is C a critical value? Yes, it's in the domain, and the derivative there is D and E. So C is a critical value. Is D a critical value? Yes, it's in the domain, and the derivative there is 0. So D is also a critical value. What about E? Yes, kind of for the same reason D was. And what about F? Yes. So really, every single one of those labeled points, which is kind of why I labeled them, are by the definitional sense critical values. But are they all going to be local extrema? No. Which two values can we immediately exclude from contention for local or relative extrema? A and F, okay? A is an endpoint and F is an endpoint, so there's no open interval containing them. All right, so here would be the litmus test. If you go to that Y value, if you look immediately to the right, you find Y values that are higher. If you look immediately to the left, you're like, I can't. So this is not a local extrema. We'll just do it like this. This is easier. All right, what about this guy here? Is this Y value a local max or min? If you look immediately to the left, you have values that are lower. If you look immediately to the right, you have values that are lower. There is nothing taller than it left or right, so this is a local max. Is he the absolute max? No, but you can see why we call him local, right? If you zoom in and you look at this local interval or this relatively small interval, he's the king of the hill. He's the highest point on this little interval. But if you zoom out globally, you get the big picture and you see he's not the global max, okay? We'll stop right there and we'll pick up with analyzing part C after lunch.